I'm going to make up a question in Numbas for the quadratic formula. So I'm going to put it in my Tech 1 project. I've already got quite a few questions in here, but let's make a new quadratic one. So we'll go up to create, click on question, and we'll call it solving a quadratic. Right, so for this question, the first thing, the part that we're going to randomize is just going to be the coefficients of the equation. So if we go to variables, first variable is going to be called A, and then we'll add another one, we'll call it B, and we'll add another one, we'll call it C. And they're just going to be the coefficients. Right? And for each one of these, we just want them to be random, so we'll just randomize them, and we'll do it for a coefficient of x squared. I guess we don't want n too big. Let's do it from -4 to 4. And again, we don't want this to be 0. Otherwise, we're not going to have a quadratic. And for b, let's make this, let's make it a bit bigger, -9 to 9. You could leave it as 0, I guess, but I don't know, let's just not have it as 0. And for variable c, same thing again, let's just make this -9 to 9 again. And let's make sure that it can't be 0. Okay. And so if we hit regenerate values, you can see that they're just bouncing about between the max and the min values that we set for them. Okay. Another thing that's going to be useful in our variables for this question is a discriminant. So let's just say disk, and that's just going to be b squared minus 4ac. So to put that in, it's just going to be b to the power of 2 take away 4 times a times c. Right. You need to remember to put in the times, because if we take out the times, it thinks that this ac is a new variable when it starts. It's saying variable ac is not defined here, so it starts kind of freaking out. So 4 times a times c, and then you can see we've got the discriminant there. And you can see that sometimes it's negative, which isn't going to be ideal for us in a Tech 1 level. We're going to deal with that a bit later, right? So we've got the discriminant, and we've got our variables. There's also, we'll make up a variable for our answers. So we'll do answer 1. And that's going to be minus b plus our discriminant, so plus disk. In fact, sorry, plus the square root of our discriminant. So square root of our discriminant divided by 2 times a. Again, I'll put 2 times a in brackets. Should be fine like it is, but just just to be sure. And it's going to bounce around like that. And look, you can see sometimes we're getting imaginary numbers kicking in. Okay, so Numbas can handle that. A lot of our students can't handle that, especially at Tech 1. So like I was saying, we'll deal with the whole negative discriminant in a wee bit. We'll add another variable, which is going to be really similar to the one here. So I'm just going to copy it and change a plus to a minus. Okay. Again, there we see our 2 values. Okay. So now to deal with the fact that we don't want a negative discriminant. This bit here, over here, the bit that says variable testing, is really useful for this kind of thing, because this lets us specify sort of parameters that we want in our question. Right. So for this one, we want our discriminant always to be above 0, right? We don't really want our discriminant to be 0 for this particular question, just to make life a wee bit easier for ourselves. Different questions you might want to be 0, but anyway. So for this one, I'm just going to set my condition that my discriminant has always got to be greater than 0. Right? If you hit the test condition, it goes through it 100 times, and it's saying here that 65.8% of the time the discriminant was greater than 0. So yeah, 2/3 of the time the discriminant was greater than 0, but what it means now is that when we hit regenerate values, you can do that as many times as you want, and it's now never going to have a negative discriminant. And that is really useful in a lot of different questions, to be able to set values that you don't want to see happen. Okay, so that's just really got all the variables sorted for this now. Now we're just going to make a statement. We're going to actually write the question. So for this, we're just going to be using LaTeX to write down the question. So we're going to start off just as normal. Solve the quadratic equation. And we're going to put in here, and the first one's going to be the variable a. So a var x to the power of 2. And you can see up here, you're seeing what that's going to look like on the screen. Plus our variable b x plus our variable c. And we want it to equal 0. And so that's it. Now, see if we hit test run now, we can see what it's going to actually look like. Right? So that one looks quite nice. But if we do this a few times, you'll start to see, look, here we've got 1x squared, that doesn't look that nice, plus 5x plus minus 1, again, that doesn't look that nice, right? So to get around that, what we can do is we can use this function called simplify, right? And then in there, we'll just put that there. You can see it's starting to not like that, right? We don't, when you're using the simplify, you don't actually need the variable part in it, right? You can see how it likes that a lot better, okay? And we'll do that for each part. And we're going to make sure that this is all in here. In fact, the x should really be in these bits as well. Simplify. Take this plus out. This is the kind of thing it takes a wee bit of messing about with just to get perfect. Right, probably leave the plus here. Take this one out and put that in there, and we'll see what that looks like now. Yeah, I've still got the plus and the minus here. What should happen now, yeah, if we've got a coefficient of 1, the coefficient has disappeared, so just minus x squared. We could do it, let's try it like this. I think this is probably the way it's going to work best. Let's see, yeah, that's his now. Okay. So you can see that it looks a lot neater now. Oh, it did look a lot neater. Right, it doesn't like it when it's got 2 pluses. This is where a lot of the time gets taken up with this, right? So the other way we could do it, we could write the whole thing out inside the simplify bracket. So if I just delete this and do ax squared plus b x plus c, this will definitely work, but the only downside of this is it's going to change the order of x squared, x in the constant. If there's a negative, it's going to put, sorry, if there's an x squared, it's going to, a negative x squared, it's probably going to put that to the back. So that one's okay. That's okay. Actually seems to be not too bad. Yeah, see this one here, because the x squared is negative, it's put the x squared in the back. There's not really much I can do about that, so we'll just need to leave it like that. Right, so we've got solve the quadratic equation, ax squared plus bx plus c equals 0. And I'll even give the students the quadratic equation using the formula again. It's going to be in LaTeX, so we need the $sign. And first thing with the quadratic formula is it's a fraction. So to tell LaTeX that we're going to put in a fraction, it's frac, and then we need two sets of the curly brackets. You can kind of see up here they've got a tiny wee fraction bit here. So we'll put in the top bit, it's going to be minus b. We don't need the variables now because we actually want the letter b in, so it'll just be minus b, plus and minus. I think that'll be just I'm going to have to look at this up. LaTeX plus minus pm. Right, so where's my thing gone? There we go. So it should just be pm. There we go. And then square root of b squared minus 4ac. And then in the bottom of the fraction, we just want 2a. Right. So we could even also put in x equals. And then put a $sign at the end to close it off. Right, so that's just got our question, and we've got our variables. The next thing is just to put in the parts. And for this one, we're going to put in the two answers. We're going to have one bit for the plus b squared minus 4ac and one bit for the minus. So to put in two answers, the thing we want to use is gap fill. And let's put in two parts. And the other thing that's difficult about the quadratic question is we're going to need to say to the students, put this answer in this box and put this answer in the other box, because we can't, the two answers can't talk to each other, so they don't know which ones should go where, sort of thing. So I'm just going to put just write this equation again. In fact, I'm just going to copy and paste it. Actually get rid of the word. And I'm just going to change this to a plus. And over here, I'll put this in here. In fact, what I'm going to do, I'm going to get rid of this x one, and we'll put our first answer box in here. So to put in an answer box, you need to put the equal sign inside LaTeX. But to specify the answer box, it's double square brackets and then the number of the box, right? So we'll start with box 0. So that looks like that. And this one here, again, we want to get rid of the x. And we'll change this part to the pm to a minus this time. And we'll put our equals in here. And then it's going to be square brackets 1 for our next box, right? We've already got one gap here. We also need to add another gap. So that's just got our two gaps, and they are both going to be number entry. In fact, this is just our first gap. We already have our answers here. So answer 1 was a +1. So a minimum accepted answer here is going to be brackets answer 1, and a maximum accepted answer is going to be brackets answer 1 as well. But that doesn't give you any leeway. You can put in precision restriction, you can say it's right to how many ever decimal places you want, let's say to 2 decimal places. Although I'm actually going to take this out for this particular question. But you can do that. You can do it to significant figures as well. What I'm going to do, because like if you're working through this question and you've rounded in the discriminant, it might throw your answer a tiny wee bit. It doesn't mean you've got it wrong, you know, but this would only accept the exact answer as it is just now. So I'm going to give a plus and minus of 1% on my answers. So I'm going to say answer 1 times 0.99 for the minimum accepted answer, and answer 1 times 1.01. Right, so that means as long as you're within plus and minus 1% of the right answer, you get the mark. Okay, again, maybe not perfect, but you know what it is in life. And we'll do the same again, add another gap, number entry, and this one here, we just need to do our marking settings, and it's going to be answer 2 times 0.99 and answer 2 times 1.01. Okay, now that should now be everything. So we test run, and this is where you always get an error. Reference to an undefined gap in a gapful part 1.1. Unnamed gap. I didn't name it. Right, let's try this again. Oh, you know what? I think I must have put in a part by mistake. That's what I did. Okay, look at this part. Right, so we've got one gap here. I think I must have put the wrong bit in. Add the gap to this part. It should be number entry. That's looking better now. Okay. Answer 2, sorry, times 0.99 and answer 2 times 1.01. Right, now hopefully it's going to work. That looks better. X squared plus 9x minus 6. Let's just cheat. What was it? X squared plus 9x minus 6 equals 0. So minus 9.62 and 0.62. Minus 9.62, 0.62. These might be the wrong way around because we've not worked it through. Yeah, so I guess if this one's going to be the 0 one. 0.62 and minus 9.62. Yeah, okay, so there we go. All right, again, when you're working it through, you should be able to put in the plus and the minus one here. Yeah, so that's it.